Share my screen. Okay, good afternoon, everyone. On behalf of Center for Air Pollution, Energy and Health Research, CAR, I would like to welcome you to our webinar today. Before we start, I would like to express my acknowledgement to the traditional owners of the land on which I work and live, and pay my respects to elders past and present. Our speaker today is Borchers Arriagada from the University of Tasmania. Nicholas is a PhD candidate in medical sciences at the Menzies Institute for Medical Research. His research interests involves the application of engineering type tools, economics, and modeling to policy-related environmental and energy problems. The presentation today is planned for 40 minutes, followed by 15 minutes Q&A. Please make sure that your mics are off during the presentation, and if you have any questions, please write them down in the chat box, and after the presentation, we will go through all the questions one by one. I also want to bring to your attention that we are recording this webinar. Thank you very much, Nico, for accepting our invitation, and the stage is all yours. Just stop sharing.
Do you see the full screen, sorry, or the presentation?
Yes, yes, all good.
All good. Okay. So thank you, Masan and Ding, for inviting me to present this. I'm doing my PhD here at the University of Tasmania, the Menzies Institute for Medical Research, with Faye Johnston. And this study is supposed to be the last, or almost last study of my PhD project. And it's the one that has been done for the longest. So I started with this idea practically from the beginning of my PhD. I would like to thank, first of all, and acknowledge my supervisory team, the first three from UTAS, and some co-authors, Owen Price, Hamish Clark, Gonzalo Sepulveda, and Steph Sampson. Also other collaborators, friends and family, and especially my funding organizations. So UTAS, Asthma Australia, and then as well as Bushfire Risk Management Research Hub, and CAR, and the NHCRC.
Sorry, Nico, to interrupt you. I think audio has a little bit problem. Can you fix it or change your
audio?
Yes, your audio? Or can you like speak louder or bring it more?
Is that better?
Yeah. Yeah.
Okay.
Yes.
Okay. So this presentation is based on the. It has been submitted to the Lancet Planetary Health, and it has been accepted early July. Not published yet. So please, I would ask you not to share these results anywhere yet. I can ask for people at CAR to let you know once it's published. This is the main structure of the presentation, typical journal article structure. Okay, so to start and give a little bit of background, so we know that recent unprecedented fire events have happened in different regions in the world, in US, Canada, Australia, Europe, and Brazil. Unprecedented being a word that we hear a lot lately. And we know that these wildfires can produce multiple impacts, from injury and loss of life, destruction of homes or other infrastructure. And there is a big disruption in productivity and the supply of resources. It could be water supply, electricity supply, or food. And the impact of interest, at least for me and probably this group, is the air pollution that's produced during wildfires. Here you can see a few figures that I've used earlier. This is from the 2019 and 2020 fire season in Sydney, and you can't see anything really. And all of this was a big issue just a year and a half ago, and then COVID came and changed things. And in the image at the bottom, you can see satellite imagery showing how the smoke produced during that fire season circumnavigated the globe and returned to the west of Australia. On the other hand, prescribed burns, and also known as planned burns, hazard reduction burn, or other names, is typically applied to the landscape to modify the fuel loads and reduce risks associated with future wildfires. How? By making them more controllable. And there are other types of approaches that exist, for example, manual thinning or mowing and grazing, but these approaches tend to be more localized, while prescribed burns are usually applied at the broad landscape scale. On the bad side, prescribed burns also produce smoke, similar to wildfires. And although they tend to be smaller in scale, they do happen closer to population centers. Why? Because they are conducted at the urban-rural interfaces, or otherwise known as the wildland-urban interface, because the main aim of these planned burns is to protect the built environment and people. And although emissions tend to be smaller because the area burned is smaller, the population exposure at sometimes can be quite substantial because they happen more frequently, closer to people, and also they tend to happen during weather conditions that generally favor accumulation of smoke, which is during stable atmospheric conditions, because the idea is that the fires don't go out of control, but that also makes that the smoke tends to stay and not disperse. This we have seen a lot in this type of presentation. So when we talk about smoke, we mainly focus on one pollutant called fine particulate matter, which is particles with a diameter smaller than 2.5 microns. You can see on the top left the diameter compared to a hair. And we're focused on this because these particles are so small that they can go into the lower respiratory tract and affect and produce different systemic outcomes. When we talk about the public health impacts from air pollution, there are many of them, and many of them we don't really see, and it can be from just having some symptoms, itchy nose, itchy throat, up to death. And usually the top three are easier to measure, but you don't see them unless large populations are exposed or people are exposed for a longer period of time. But they are easier to measure and also easier to value in terms of monetary terms. So there is a method called health impact assessment. The study one, first study summarizes the methods, and these methods have been used extensively for air pollution, mainly for urban air pollution. They have been used a lot in the US to assess air quality regulations, and also in Europe. In Australia, not so much. And then in the recent years, I would say maybe in the last 5 to 10 years, these methods have been used to assess the impacts of bushfire smoke or wildfire smoke. And for example, study 2 was done in the US, study 3 in Canada, study 4 was a study done at a global scale by my supervisor, Faye Johnston. Study 5 by Richard Broom to assess the impact of hazard reduction burns in Sydney during 2016. And 6 was a study I did as part of my PhD similar to this one, but at a smaller scale for Western Australia, and just looking at exceedances of air quality standard. So in this study, New South Wales is an ideal setting to do this type of analysis. So a health impact assessment associated to bushfire smoke. Why? For different reasons. There's a large area of eucalypt forests close to population centers. There's a long-standing program of prescribed fires that are used to manage wildfire risk. And so some studies in this area have shown that to effectively reduce the area burned by a wildfire, you need to burn more area through prescribed fires. So about 3 times in terms of area burned or more. New South Wales also has a reliable fire history, or at least more reliable than other states, a really well-developed air quality monitoring network with publicly available data, and also regularly updated health statistics, which not all states really have at this level detail. So the objective of this study was to apply these methods, a health impact assessment framework, to estimate the health costs of PM2.5 attributable to wildfire smoke. I will refer to that as WFS, and prescribed burning smoke, PBS, in New South Wales for a 20-year period, so July 2000 to June 2020. And we also sought to estimate a per hectare health cost indicator that we could propose be incorporated for fire management practices. This figure shows the process that we followed. So it was three main processes. Top left, we did an analysis of a fires database. In this case, it's the National Parks and Wildlife Service, NPWS, fire history. Then we, on the other hand, we quantified daily health costs across Australia. And then we combined these two to estimate costs per fire type and then costs per hectare. So if we look at the top left figure, we took this database and we had to put it into a database cleaning procedure. Once we clean the data, we applied the random forest model, I'll explain a bit later, to classify days by fire type. And the output of this analysis was area burned by fire type per day and day classified by fire type. Then on the top right, this is the typical health impact assessment procedure in which you combine population with exposure and health risk coefficients to estimate the health impacts and health costs. And an additional aspect we included is right on the right, is that we used a random forest model combined with the particle elemental component studies to identify proportions of wood heater smoke and exclude this from the analysis. And as you can see at the bottom, we did a statewide analysis, a regional analysis, and a sensitivity analysis. So the special extent or our regional analysis, we used as the main spatial unit of analysis all of New South Wales, but we also disaggregated the spatial extent to the NPWS branches shown here. Okay, so first of all, this fire database is really complete in terms of data. We have information on a fire season, which usually starts in July and ends in June, so it's similar to a financial year. Fire type, start date, end date, and area burned. Those were the main variables that we used. But there are some limitations because there's errors, as there are errors on any type of database. For example, there are duplicate fire IDs or wrong missing end or start or end dates. So we had to do a cleaning procedure that would allow us ultimately to estimate a daily area burned for each fire and each fire type. So initially, first we identified fires with wrong or missing dates. So it could be incomplete start date or end date or mixed up dates or dates out of range within the fire season. And then we also identified the fires that likely had complete dates. And for these fires with complete dates, we estimated the daily area burned. So that is the total area divided by the days active. So we used the days with the fires with complete dates to calculate a daily area burn distribution per fire type and fire season. And we assumed that this was the correct area burn distribution. And then we imputed that same distribution across all fires with wrong or missing dates. This is a bit complicated, so if someone wants to ask something, we can come back to this. Then, once we fixed up the dates and the daily area burn, we needed to identify or classify the likely dominant fire smoke type. So PBS, prescribed burning smoke, or wildfire smoke. So the first step we did was to calculate for each day the proportion of area burned by a wildfire. So we would take on one day all the fires that were burned by a wildfire, all the fires burned by a prescribed burn, and we calculated a proportion. So this, if you have that value percentage hectares wildfire, if that is 1, that means that on that day, all fires were wildfires. If that was 0, all fires were prescribed burns. So because not all days were either 1 or 0, there was a mix of, in some days there was a mix of burns going on. We applied a random forest model that would help us classify each day according to the likely dominant LFS category. So LFS here is landscape fire smoke. Okay, so the first step was to identify the days that were dominated by wildfire smoke. So with area burned above 90%, or were dominated by prescribed burning smoke. So wildfire area burned less than 10%. And this, we assign this as training data. Then we train the random forest model on these variables. So year, month, week, weekday, fire season, area burn, temperature, and different variables using the carrot package and the R software. And once we had this model, we predicted on
and we'll
days.
pay you for it.
Yeah.
Jeff,
So I'll just do 60 an hour.
Yeah.
Okay. Then we use this trained model to predict on days that were not dominated by either wildfires or prescribed burns. I'll show you, because of this method, we also did a sensitivity analysis just to make sure. Then the quantification of costs, it's the typical health impact assessment. You can see the equations on the left, and then the process here in the figure. So initially we need to estimate the change in PM 2.5, identify the exposed population, combine that with baseline incident rates, betas, which are health risk coefficients, and that allows us to estimate the number of cases, as this equation on the top left shows us. And then we combine the number of cases with unitary cost, and we estimate smoke-related health costs. PM 2.5 exposure, that's one of the main drivers for this analysis. So we estimated a LFS exposure, so the daily PM 2.5 for LFS days, the difference between the daily PM 2.5 and the long-term mean by say 2 months. And we identified the LFS days as those days where PM 2.5 was above the long-term 95th percentile. We also, knowing that there could be days with high pollution, not due to fire smoke, we excluded identified dust storms. And so, as I told you earlier, we used this random forest model to estimate the contribution of wood heater smoke on days when this was likely to happen. So this heating degree days above 0 or average daily temperature below 18 degrees Celsius. We use data from studies by Stelzer, Hibbert, Cohen, Keywood, which are particle characterization studies, which have been done to identify and estimate contribution of different polluting sources to daily PM 2.5 composition. So we compiled these studies that were available for 10 different sites near Sydney and the lower and upper Hunter Valley for different periods between 1998 and 2015. So practically quite a lot of our study period. And the stations that are located near Sydney and Newcastle had really good detail of data. So daily or sub-weekly results for at least 10 years. So we had a lot of data to train a model. And we trained the model with this shape. So WHS PM2.5, that is like wood heater smoke PM2.5. We used daily PM2.5, temperature, heating degree days, relative humidity, and location, represented by lat long. And we excluded days that were identified as landscape fire smoke days, just to make sure that we only included winter wood heater smoke days. Health data. This is a bit different to what I've done in other studies, and mainly because New South Wales has more level of detail in the data that they publish. So the first 4 rows show, we assess this for outcomes, all-cause mortality, cardiovascular hospitalizations, respiratory hospitalizations, and asthma ED visits. And on the right, you can see the baseline incidence rates. So that is cases per 100,000 persons. And you see a range because we actually have a value with a confidence interval for each year. That's not available for each state, but for New South Wales, so that's really good. And the same thing, population, you can see a range because we used yearly population by SA2. And this is the data that we used, the health risk coefficients and the unit costs. You can also see the 95th% confidence intervals for the costs, for the health risk coefficients, but not for the costs. And so in terms of mortality, this value is was originally estimated through a method called willingness to pay. And these 3 values, which is morbidity, costs, through a method called cost of illness, which is actually the average cost of one cardiovascular hospitalization or the average cost of one asthma emergency department visit. And all costs were adjusted by consumer price index to $2018. And then, so once we identified the fire type days, and then we estimated daily landscape fire smoke costs. We combined them, and then we estimated costs per area burned with just this simple linear equation, where the health cost on the left is the total estimated health cost for the fire type aggregated for a time variable t, which could be days, weeks, months, years. Beta naught is the intercept. In this case, we assume it was 0. So this means that if no area was burned of any type of fire, then on that day or on that time variable, there wasn't any landscape fire smoke attributable health impacts. Area burned was the total area burned by fire type, FT, aggregated for the same time variable, and then beta 1 is the regression coefficient or the slope. In this case, it's the health cost per area burned. And we would get results such as this one, which is for all fire days. You can see this is aggregated by fire season, and you can see the equation on top. This would tell us that 1 hectare burned on average would cost $370 in terms of health costs. This is for the whole period. I'll show more results later, but this is the type of analysis we do. And the sensitivity analysis. So because the random forest model could have been a bit tricky, or there could have been some error in the way we classified days, we also looked at 2 more classifications. One was season, mainly because seasons are strongly dominated by one type of smoke. So during summer, wildfires; during autumn or spring, it could be prescribed burns; and during winter, wood heater smoke. And then we also included a simple categorical classification. We have these 4 categories. The category on top, that means wildfire area burned between 0 and 10%, and prescribed burn area between 90 and 10%. So this would represent mainly prescribed burns. And then the category at the bottom would represent mainly wildfires, and the 2 in the middle are just transition or mixed days. Also, because of the fire database date errors and the presence of lags between smoke production, exposure, onset of symptoms, we varied the time between variables. So we look at the equation I showed earlier. We aggregated the costs and the hectares by day, week, month, year, and fire season, and just looked at how the model would perform across those different time group and variables. We also looked at what happened when we excluded the fires that we identified as having wrong or missing dates, and also what happened when we excluded extremely relevant fire seasons, as you will see in the 2002 and 3 and the 2019-20 fire seasons, which could have biased the average results for the period. And we also included the 95th percentile confidence intervals for the baseline incident rates and the health risk coefficients. Okay, so now to the results. this is just a characterization of the fire. So after cleaning the database, we counted or estimated over 15,000 fires across the 20 years. More than 60% were wildfires, and more than 12 million hectares burned, and more than 90% of these were from wildfires. We also identified that 32% of fires or 24% of hectares had wrong or missing dates, and that most fires happened during summer or spring, so around 75% or 86% of the hectares. So this satisfies our assumption of wildfires being during that period. And then we can see from this figure, so on the top panel, you have prescribed burns, in gray, number of fires, in red, area burned, and in the bottom panel, wildfires. You can see that although the number of fires are pretty similar in both cases, the area burned is really small for prescribed burns. And in the case of wildfires, you can see that during 2002, 3 and 2019-20 were the worst in terms of area burned, but the 2002-3 was the worst in terms of number of fires too. So our results. So for this 20-year period, we estimated just around 2 billion, not million, 2 billion Australian dollars in terms of health costs, 82% due to wildfires, and similar results when we excluded fires with wrong dates. When we look at the categorical variables, they are pretty much in line. So just under 80% for the dominated by wildfires. Just same during summer, spring, and more than half due to these two wildfire seasons, fire seasons, mainly the last one, which was huge. And this figure is pretty similar to things we published earlier. Sorry. This was like the main result. On the left, you can see 3 panels. So the health costs estimated for per hectare for all landscape fire days, wildfire smoke fire days, and prescribed burning smoke days. And on the right, the same figures, but excluding the 2002-3 and 2019-20 fire seasons. You can see on the panel on the left that there's some leverage to some fire seasons that's not seen on the panel on the right. And here you can see that's the cost of wildfire smoke days, $104. And this is the cost, sorry. And for prescribed burning days is 477. So that's the cost per hectare is 4 times for prescribed burns. This table shows a bit more the same thing, but summarized a bit better. So on the top, it's the random forest model, all days, all fires, and on the bottom, just the fires with correct dates. And here we have all fire seasons and excluding 2002 and 2019. And we estimated this ratio, so PBS-WFS ratio, which tells us how much larger is the cost per hectare for prescribed burning smoke. And on the main analysis, we have that value is 4.6 times. It could have been biased by some fires. So when we exclude the fires with incorrect dates, we get a ratio of 4. When we exclude these 2 big fire seasons, which really biased the results because the area burned was so large, we still get a ratio of 1.4 or 1.2 if we exclude wrong dates. We also identified that on many cases, there are, we call them inter-branch impacts, or there are inter-regional impacts. It means that fires happen in some locations and affect populations in others. And you can see, for example, here in the top, in gray is the area burn, and in red is the costs. So for example, you can see this spike in area burn here in the West Branch, producing some spike in costs in other branches in the Greater Sydney and Blue Mountains. Hunter Central Coast branch and here in the southern branches. And the same thing happens here, that you have for this fire season, the previous fire season, you also have some burning happening in some branches and affecting, for example, the west branches in terms of costs. And we reinforced these results by looking at a correlation matrix between the area burned and the costs across different branches. And for example, here you can see that the north branch, the area burned in the north branch correlates really well with the costs in the Greater Sydney and Blue Mountains branch and in the Hunter Central Coast branch. And the same thing happens with the area burned in the Hunter Central Coast branch. There is a big correlation with the costs in the northern branch, costs in the southern branch, and costs in the western branch. So to our knowledge, this is the first study that really does a thorough assessment of the relative health costs associated with wildfires and prescribed burns. In terms of magnitude, we found that in the previous 20 years, this is maybe was a bit expected, not that the impacts were dominated heavily by wildfire smoke. So we have more than 60% of fire events, 90% of area burned, and more than 80% of health costs happening mainly during spring, summer, with a high variability through years, and dominated by mainly 2 fire seasons, and mainly the last one, 2019-20, which takes about half of the impacts. We found substantial impacts, increases in PM2.5. So we didn't show these results here, but in terms of average annual exposure, more than 1 microgram, which is quite relevant in the Australian case, in which in New South Wales, the long-term mean, annual mean is around 6.6 or 6.7 micrograms. So you have that more than 1 microgram has been due to landscape fire smoke. And these results are very in line with what happens in other places. So in the US, here, Fan et al. Estimated that 30% of the population has a similar exposure, around 1 microgram, and 10% of the population above 1.5 micrograms. In Canada, this could be a bit worse. So for example, lower than 1 on average, but up to 5 to 10 micrograms for some years. And that's similar to what we estimated an average annual exposure of 1.86 with up to 7.2, for example, for the previous fire season. So when we looked at international evidence, not in terms of air pollution mainly, so other studies have looked at the relative impacts of wildfires and prescribed fires. There's a systematic review that was done in the US that found some contradicting results. So PM exposure to wildfires was significantly lower to that of prescribed burns, but there were very strong differences in the methodologies used. Mainly that PM during wildfires was measured far away, and during prescribed burns is measured closer. But Jaffe et al. Did another study last year, and they found that the maximum daily PM2.5 tended to be higher for wildfires compared to prescribed burns, even though these two had similar magnitudes of area burned. This was only for the top 5 states for area burned in the US. And they also found that for that period, 2004 and 2018, there was a positive association between the percentage of monitored days with exceedances and area burned. So there was some coupling between fire activity and PM2 air quality. And so these results, Jaffe et al. Are in line with our findings. So PM2.5 exposure higher for wildfires and air quality coupled to area burned. In our case, not air quality, but health impacts, which is driven by air quality. In Australia, Owen Price and collaborators, they assessed the impact of 2 prescribed burns of different areas, a small one 52 hectares, a large one of 700 hectares. And they found that the small burn tended to produce larger PM2.5 spikes, but when you were close to the burn, so less than a kilometer downwind, but the larger event might have produced larger PM2.5 levels farther away, so up to 14 kilometers. And they found that the smoke reached really high levels above 1000 micrograms or daily averages above 200 micrograms. So they concluded that prescribed fires can produce high local impacts and lower regional level impacts, but they both increase with fire size. And this situation has also been observed in Australia, mainly in New South Wales, with some prescribed burning events producing similar large air pollution episodes to those observed for serious wildfire events. So I showed earlier the study done by Richard Broom, looking at the 2016 prescribed burns in May. And that's an example of what the impact that could be seen. Some limitations and strengths. So we mainly identified 3 limitations besides all the limitations that this type of analysis, health impact assessment and assumptions, but we used administrative data to identify individual fire events. We could have used probably other means, satellite data, smoke plumes. We didn't do that. We just believed in administrative records of fires. Also, the way we linked a fire type day to landscape fire smoke affected days. So we tried to do this daily and then looked at different time aggregations by week, month, etc. And this affected the way we estimated the health cost per area burn. Maybe there are other methods also looking at lags, but we use this simpler approach. But we did try to manage the potential errors that, for example, the errors that were present in the fire history database. We tried to overcome this limitation by performing some additional analysis and presenting our results, for example, excluding fires with incorrect original dates. And we saw that this didn't really produce a big impact in our analysis. We also looked at different time aggregation, so days to years, and classifying the fire type days by other categorical variables, so season or the fire type categorical I showed you. And also there is a large consistency in our results. So initially, my idea when I started the PhD was to do this by individual fires, and while the project was ongoing, I found this to be particularly difficult and complex. So we decided to take this approach. We did find very surprising results. We weren't expecting this really. Is that the per hectare costs are higher for prescribed burns than wildfires, and some of the reasons for this could be that, for example, the surface from wildfires is larger, so the denominator is quite large. This could bias the results, but also we have that prescribed burns tend to happen closer to people. I told you earlier that the objective of prescribed burns is to protect the built environment, and also they tend to happen when weather is more conducive to producing smoke impact, so stable weather conditions. But our results, again, what's the potential of our results? So the current evidence for New South Wales shows that to reduce the risk of burning of 1 hectare by a wildfire, you need to burn between 3 to 6 hectares of prescribed burn. So it can be expected that if everything keeps going as it is, and if our results are correct, we have that the per hectare cost of prescribed burn compared to wildfires vary between 1.4 to 4.6 times. So it would be expected that the smoke impacts of prescribed fires may produce health costs up to 4.2 to 27.6 times larger than the avoided wildfire smoke impacts. Yeah. This doesn't mean that prescribed burns are worse than a wildfire and that we shouldn't do prescribed burns, but it just means that fire smoke health cost is one of the many dimensions of a really complex fire management dilemma. We also have in this equation climate change, and it is likely that there will be an increase in frequency and intensity of fire seasons, and the seasonalities and availability of days with ideal conditions for prescribed burns could change or be reduced. So the complexity that was already there is increased. And given these results, we think that fuel management programs should increase in extent and diversity and trying to include other alternatives to prescribed burning. And also that there should be an increase in the mitigation systems to mitigate smoke exposure. Knowing the difference between a prescribed burn and a wildfire is that when you're burning, you know that you're burning. You could forecast smoke, but wildfires, it's out of control. We don't really know when it can happen and why. So there is some interventions we could do. Thank you.
Okay, thank you very much, Nico. Very interesting study. Here we open the session for Q&A. Please go ahead and type your questions in the chat box. Okay, the first question is from Tim. Tim, would you like to open your mic and ask your question?
Yeah, thanks, Nico, for your talk. It was great. We're all obviously extremely interested in this area, and we're all also aware of the need to really focus on how we can use prescribed burns to protect ourselves from the wildfires of the summer. It's a little alarming to see that the prescribed burns are so have such larger health costs than the wildfires. And I wonder if you did an analysis where you only included wildfires in areas that would be subject to prescribed burning. I wonder how that ratio of costs would change.
We not really, but we did look at, I don't have the results now, but we looked at these ratios for each of the branches. So each of the of the National Parks and Wildlife branches. And we did find, well, you can see from this image here that there are some branches here. We have 5 branches that are grouped, but some branches would have more costs than others, and that it's mainly, for example, around Sydney, Greater Sydney, and the Blue Mountains, and what happens in the Hunter Central Coast branch, so near Newcastle. Those would be most affected because they have larger populations and forests. That was all the regional analysis we did.
And these are the wildfire impacts rather than the reduction.
No, yes, but we did look at the impacts of, for example, the cost ratio between the prescribed burning and the wildfires across these different regions. And the same we saw, although with different magnitudes, it was the same direction. So always or almost always, the cost per hectare for prescribed burns was higher than the costs for wildfire smoke.
Thank you.
Although, well, we've discussed this. These results should be put in an equation that includes all of the costs. No? So infrastructure, injury, death, management, all the costs. It's a mix of in the equation.
Thanks, Nico.
Thank you.
Thank you. Thanks, Tim, for your question. And the second question is from Michael. Michael, would you like to open your mic?
Thanks, Marsan, and Nicholas, well done. I really enjoyed that presentation, and I very much look forward to seeing the paper when it appears in Lancet Planetary Health. I mean, it's so nice to actually have some evidence, because as you'd be aware, and I think most people are aware, there have been very passionate debates about this issue, but almost entirely uninformed by evidence. So you've, to some extent, answered the question that I had, and that relates to the direct health costs. So you've focused very much on the costs of air pollution, which is clearly something that interests everybody on this Zoom. But I just wondered about other costs such as burns, injuries, post-traumatic stress disorder, and so on. I mean, I am aware that sometimes these prescribed burns get away, So even though people are not supposed to be burned or injured, maybe it sometimes happens. So what are your thoughts about how those costs could be incorporated?
Thanks, Michael. I haven't really looked at that. I've read some stuff, but especially in the beginning of my PhD, there are people looking at including costs, but I haven't seen studies that really take into account all costs. So for example, studies that look at those costs, they don't include health impacts. And studies that look at health impacts don't include those other costs. But that could be done. You could look at just different scenarios or in history what has happened with a really broad spectrum of cost types or cost groupings, like you said, like injury, infrastructure, post-traumatic stress disorder, other health outcomes, and do a really comprehensive assessment of the costs and the benefits of doing prescribed burning. And you would probably find that not doing prescribed burning is not the solution, but given that it's something that's controllable, you might want to think better on when to do prescribed burning. But that's my output to this analysis. It's
Yeah, I think your point about climate change is absolutely right. The window to do prescribed burning is going to close over the next few years. Anyway, thank you for responding. I should let other people ask some questions.
Thanks, Mike.
Okay, thank you. Thanks, Michael, for your question. David, would you like to open your mic and ask your question?
Yeah, so I think one of the things that the most, I think, useful part of this research is in the bushfire community is to actually throw down the challenge of trying to understand the economics of bushfires and bushfire management. So what is a bit surprising is we actually don't know, there's not a reliable costing of a per hectare prescribed burn or a cost of fighting a wildfire. So those data, as far as I understand, Owen might want to say something about this, extraordinarily difficult to extract from the fire agencies. And so what you're effectively doing is in this research, is you're identifying a corner of the problem, but we haven't actually identified the whole problem. So that one of the, sure, there are trade-offs between wildfire and prescribed burning, but we don't know the health costs relative to the cost of actually doing the prescribed burning and fighting the wildfires. And to me, that's an astonishing thing, that in fact, health economics seems to be leading the charge here rather than coming from the fire managers. I'm not across bushfire economics. Owen might have some better observations, but that's what I've learned. It's very difficult to get accurate numbers of what all this is costing.
Thanks for putting me on the spot there, David. Yeah, I would just say the same. It's extraordinarily difficult. All of these things are somewhat abstracted measures we're trying to get, because it's very difficult to get to the precise numbers about what happens at fires, both prescribed fires, and then how that plays into what happens in wildfires afterwards. But Nico's is a great contribution to answering that question.
Thanks, Owen and David.
Okay, thank you. Thanks, David and Owen. So next comment is from Jeff Morgan. Thanks for your comment. Would you like to open your mic and ask the question?
Yeah, hi, Nico. This is a sort of relatively unformed question, but my limited understanding of hazard reduction burns is that the benefits of them in relation to reducing wildfire risk is that it depends on the scale of the wildfire. That some fires are so big that nothing much is going to get in their way. That's probably a very crude description of a complex science, but so you looked at the relation between prescribed burning and wildfires. Have you seen anything of that sort of non-linear relationship between the two? If it exists, or can you get at that?
No. For this case, we sort of looked at the fact that large wildfires are not affected by prescribed burns when we actually excluded the two largest fire seasons, so that sort of gives you a sense of what would happen without the large fires. And for the cost per hectare, we assume the linear equation. So yes, there's a lot of assumptions there.
Thanks.
Yeah, I think that this type of analysis should be taken a bit further, looking at maybe different types of prescribed burns and different types of wildfires, and there's a lot that can be done with this information.
Okay, thank you. Thanks, Jeff. And the next comment is from Hamish Clark. Would you like to open your mic?
Oh, no, I didn't have a question. Thanks. I was just responding to something someone else had said in the chat window.
Oh, okay.
Nice to talk, Nico.
Okay. Yes, thank you. Thank you, everyone, for joining us today for this webinar. And thanks, Nico, for your presentation. Here I would like to wrap this session and wish you all a great weekend ahead. Hope to see you in our next webinar. Thank you.
Yes, thanks for inviting me, and thank you, everyone. Bye.